So in this lecture, let us consider an example for discrete time systems. So in the last lecture, we have discussed the frequency response of a discrete time system and the eigenfunctions also. Okay, so let us take an example. We have taken this example earlier also. So I am going to consider m point moving average system. Okay, so the output at any instant is the average of all x of n, right? You take the average of all x of n starting from the present instant k is equal to 0 to m minus 1. Here this m is a capital M minus 1, and the running variable is k here, k. I'm sorry, this is n minus k. That's it. Okay, so in the time axis, if you consider, so you are adding all the values up to x of n, and this is x of n minus 1 dot 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 up to x of n minus m plus 1. So this all values are added up. Okay, and this x of n is the present input, and m minus 1 past values, right? So if we expand the summation, then this is going to be 1 over m, then x of n plus x of n minus 1 plus x of n minus 2. Let's say m is equal to 8. So plus up to x of, you'll get a n minus 7. This is what you'll get at, right? So this is my y of n. Now if you substitute n is equal to 0, then you will be having 1 over m is 8, then 1 over 8, x of 0 present value, and x of minus 1 plus x of minus 2 plus dot 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 up to x of minus 7. So you are considering 8 sample values, 1 present sample value and 7 past sample values. Similarly, you can substitute different value for n. If you substitute n equal to 1, then y of 1 is equal to again 1 over 8 and blah blah blah. So therefore your average is moving when this n value is moving. Now you can ask a question, what kind of system is this? Is it FIR or IIR? FIR, because h of n is nothing but 1 by m, 1 divided by m, summation of, this already we found, okay, in one of the lecture, del of n minus k, where k is equal to 0 to capital M minus 1. So since your impulse response has finite number of samples, then the system is FIR system, finite impulse response system, because h of n is nothing but 1 divided by m summation del of n minus k, k is equal to 0 to m minus 1. Therefore this is finite impulse response system, because the summation is up to a finite number, capital M minus 1. If it is infinity, if the upper limit is infinity, then you can say infinite impulse response system. Okay, now this h of n can be written as, if we expand this, then h of n is equal to 1 over m del of, and substitute k is equal to 0, k is equal to 1, k equal to 2, 3, 4 and so on, then del of n plus del of n minus 1 plus del of n minus 2 plus dot 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 up to del of n minus capital M plus 1. Okay, therefore this del of n has the value when n is equal to 0, and this guy has the value 1 when n is equal to 1, this guy has the value 1 when n is equal to 2, and so on and so forth. Therefore this I can say 1 over m 1 comma 1 comma 1 up to m minus number of ones, then this is n is equal to 0 point. So in short form, in compact form, I can write this h of n as 1 divided by m when n lies between 1 and 1 or 0, 0, capital M minus 1 and 0 otherwise. So this is the compact way of writing h of n. So it is indeed an FIR system, right? Its frequency response. How will you find out its frequency response? For frequency response, all we have to do is take the DTFT because it is a discrete time system, right? So if it is continuous, you might have taken CTFT, continuous time Fourier transform. If it is a discrete time signal, then you take DTFT. Therefore, capital H of e to the j omega is equal to summation h of n e to the minus j omega, and this is the formula where n goes from minus infinity to plus infinity. But anyway, this h of n has only finite number of values, so I can write n is equal to 0 to m minus 1, then h of n is 1 over m e to the minus j omega n. Therefore 1 divided by m, expand the summation, 1 plus e to the minus j omega plus e to the minus j2 omega plus dot 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 e to the minus j omega capital M minus 1 times omega, right? So this is the geometric series. Okay, we can sum it up. So the summation is going to be 1 over m 1 minus e to the minus j omega capital M divided by 1 minus e to the minus j omega, and this can be written in terms of sinusoidal functions. Like what you can do is 1 divided by m 1 minus e to the minus j omega m divided by 2 times e to the minus j capital M omega divided by 2 divided by 1 minus e to the minus j omega by 2 times e to the minus j omega by 2. This j omega m I can write as like this. Similarly, in the denominator, I have e to the minus j omega that can be written in terms of these two factors. Okay, now 1 over m, then you take e to the j omega m omega by 2 commonly outside. So e to the minus j omega capital M by 2, within a bracket I should have plus here, plus j omega m by 2 minus e to the minus j capital M omega by 2. I should follow consistent notation. Omega capital M by 2 whole divided by, in the denominator also take e to the minus j omega by 2 commonly, then e to the plus j omega by 2 minus e to the power j omega by 2. Now you can introduce 2j in both in the numerator and denominator, then it is 1 over m e to the minus j omega m by 2 times e to the plus j omega by 2. This I am bringing to the numerator. So now the numerator function becomes sine of what? Omega m by 2 divided by sine of omega by 2. Now simplify this guy. This is 1 divided by m e to the minus j omega you pull out. So m minus 1 divided by 2 sine of omega m by 2. This is capital M divided by sine omega by 2. What is this? This is the frequency response of moving average system. Now it is very tempting to identify. Okay, maybe let me rewrite this. Capital H of e to the power j omega is equal to 1 divided by capital M. In the numerator I have sine omega capital M by 2. In the denominator I have sine omega by 2 multiplied by e to the minus j omega times M minus 1 by 2. Now look at this expression. So it is very tempting to identify this as the magnitude and this as the phase, isn't it? Phase, and this guy as the magnitude. Okay, but which is not correct. If you say this is magnitude and this is phase, then that is not correct. I will tell you why it is not correct. Because you consider this guy, sine omega capital M divided by 2, sine of omega by 2. This itself has variations. Okay, this guy itself has change in sign. Changes sign. Okay, whenever it changes sign, the phase changes by how much? 180 degree, because it's a sine function, right? So it keep on alternates like this. For every 180 degree, there is a phase reversal of pi. Okay, here it is positive and here it is negative. Positive and here it is negative. There is a phase shift. For example, if I plot sine omega m by sine omega, this is a sine function, by the way. If I plot this guy in the y-axis, let me take 1 over m sine capital omega m divided by 2 divided by sine omega by 2. In the x-axis, let me take omega. So what do you think when omega is equal to 0? I am taking this guy, substitute omega is equal to 0. You will get 1 divided by m sine 0 by sine 0. It is indeterminate form. So you use L'Hospital rule, right? So differentiate numerator and differentiate denominator independently. So 1 over m, numerator becomes what? Capital M by 2 cosine of omega capital M by 2. In the denominator, 1 by 2 cosine of omega by 2. Now this m and that term will get cancelled. This 2 and that 2 will get cancelled. You are left with cos capital omega m by 2, cos omega capital M by 2 divided by cos of omega by 2. Now substitute omega is equal to 0, 1 by 1, it is 1. Therefore the peak value is 1 in the y-axis, and then it comes down, it oscillates like this. So this is my first zero crossing point, right? It executes damped oscillations. It executes damped oscillations. Say, let's say this amplitude is bigger than magnitude of this amplitude, and magnitude of this amplitude is bigger than magnitude of this amplitude. Of course, I did not draw the diagram as per the scale, but the amplitude of the oscillations are going down. That is the meaning of damped oscillation. If I draw neatly, I'm sorry. Like this. Let's say this amplitude is V1 and this is V2 and this is V3. So if you take the magnitude of V1 is greater than magnitude of V2, which is greater than magnitude of V3, and so on and so forth. That's what we mean by damped oscillations. Now up to this point, you take this point up to this point, where does the first zero occur? When the angle becomes equal to pi, right? So this omega m by 2 becomes pi, because sine pi is 0, right? So omega capital M by 2 is pi. Therefore omega is equal to 2 pi by capital M. So therefore this point is going to be 2 pi divided by capital M. And what about this point? This point is 4 pi by capital M, and this point is 6 pi divided by capital M, and so on and so forth. So when omega is equal to 2 pi by M, the numerator of this function becomes 0. Sin omega M by 2 will be 0. Therefore, omega is equal to 2 pi by M is the first 0. Right? At omega is equal to 2 pi by capital M, the denominator remains non-zero. Okay, so denominator is not 0, but the numerator is 0. And in between this point and this point and this point, the angle would be what? Negative. Okay, here it is positive and here it is negative. How much? Minus 180 degree. So at every such transition, the phase will change by how much? 180 degree. Okay, when 0 to pi, it's positive, pi to 2 pi, it is negative, 2 pi to 3 pi, it is positive, and so on and so forth. Okay, this is my h of magnitude of h of j omega, right? Like this it oscillates. Y-axis 1 over m sin omega capital M by 2, denominator sin omega by 2. This is omega. This is nothing but what? Magnitude of the frequency response. Sorry, only a plot h of e to the j. Sorry, I'm not even that. I'm sorry. Now, if I take magnitude of that, what is the magnitude? Look at this function. Yeah. Now, what is the magnitude of this? If you write down magnitude, h of e to the j omega. If you take magnitude, this phase term will disappear. So this is simply 1 divided by m sin of omega capital M by 2 divided by sin omega by 2. Therefore, if you plot the magnitude, so this negative part becomes positive. This is h of e to the j omega magnitude, and this is frequency. This is 2 pi by capital M, and this one is 4 pi by capital M, 6 pi by capital M, and so on and so forth. At every such a transition, the phase will change by pi. So if you take magnitude, the negative half, where is the negative half? This one. The negative half will flip over. Okay. It will flip over to the positive. So the magnitude plot will be like this. This is the magnitude plot. And therefore, the magnitude and phase of the frequency response can be written as h of e to the j omega. Magnitude is going to be 1 divided by m sin of omega capital M by 2 sin of omega by 2. So this is magnitude. What about the phase? The angle h of e to the j omega is given below. We know the expression for h of e to the j omega. What is the expression? 1 divided by m sin of omega capital M by 2 whole divided by sin of omega by 2 e to the minus j omega m minus 1 whole divided by 2. Right? So from this expression, how will you find out phase? So it is explicit that this is a phase term, no problem. But this guy also introducing phase, discrete phase. Suddenly it increases, it contributes, pi. Okay, you see the angle would be explicitly minus omega times capital M minus 1 divided by 2, no problem. Also, you have to take care of phase transitions by pi wherever there is a 0 crossings. Whenever the function crosses 0, there is a phase transition. How much the phase transition would be? Pi. Okay, an angle pi is added with this guy. So with this guy, you should add the angle of pi. Okay, therefore the phase angle is going to be minus omega times capital M minus 1 divided by 2 plus there is a phase angle. How much it is introducing? Pi. Okay, so at what point the plot crosses 0? When omega is equal to 2 pi by capital M, and here omega is equal to 4 pi by capital M. So whenever it crosses 0, there is a phase shift of 180 degree will be introduced. Therefore this changes will be accounted as follows. So you should include phase angle pi when the omega changes from omega comes at 2 pi by m, 4 pi by m, 6 pi by m. Therefore omega minus 2 pi by m. Right? When first 0 crosses 180 degree and again second 0 crosses another 180 degree. Therefore let me put k. When k is equal to 1, you will get the first transition. Right? When k is equal to 2, you will get the second transition. When k is equal to 3, you will get the third transition. That is, you will get, when k is equal to 1, you will get 2 pi by capital M. When k is equal to 2, you will get 4 pi by capital M, and so on and so forth. I mean u of omega minus 2 pi by m, then u of omega minus 4 pi by m, and so on and so forth. Therefore whenever it crosses 0, there is a phase shift of how much? Pi degree. Okay, that phase also I need to add here. So del of omega minus 2 pi by capital M times k, and let me sum up this phase. K is equal to 0 to how many phases would occur? Okay, from k is equal to 0 to how many such transitions will occur? Our range of vision is, I cannot go this up to infinity. This is wrong. I cannot write like this, because in the discrete time domain our range of vision is from omega is equal to 0 to omega equal to infinity. Omega is equal to pi. I cannot go beyond pi. Therefore sin omega, in the numerator I have sin capital omega m by 2. When it becomes pi, then the transition stops. Okay, I cannot go beyond that. When the argument becomes pi, then my transition would stop. I cannot go beyond that. Okay, so I mean, let me start. This is 0 and this is 2 pi by capital M, and this is 4 pi by capital M, and this is 6 pi by capital M, and let's say this point is M. So between 0 to M, how many such 0 crossing points would occur? This is first 0 crossing point, second 0 crossing point, third 0 crossing point, right? Third 0 crossing point. This is second 0 crossing point. Like this, how many 0 crossing point would occur between 0 and M? So the total length is M and the interval is 2 pi by M. I'm very sorry. This is M. Because our range of vision, as I said, 0 to pi, right? Omega is equal to, because this is my omega axis. So let me start from 0 and go all the way up to pi. Therefore the total length is pi, and each interval, this interval width is how much? This is 2 pi by capital M. So how many 0 crossings will occur? Total length divided by this length. What is that length? 2 pi by capital M. That M we don't know. Let us assume that it is capital M. Maybe 8, maybe 16. We don't know. So here the total length is pi, and 2 pi by M pi will get cancelled, so it is m by 2. How many transitions? M by 2 transitions. In case if m is not a integer, then what will you do? In case if you take 7, then how many transitions? You can't say 3.5 transitions, it is wrong. Therefore, you have to take the integer value. Okay, so in the summation, you have to take capital M by 2, but you take the floor function. This is called a floor function. I can take the floor function. If I write like this, this is called a ceiling function. Okay, largest integer of m by 2. Okay, so if I write like this, floor function, what does it mean? It indicates integer closest to m by 2, but not less than m by 2. Sorry, but less than m by 2. Closest integer closest to m by 2, but less than m by 2. For example, as I said, when you take m is equal to 9, then 9 by, let's say 8, or no, let us take 7. 7 by 2 is 3.5. So closest integer to m by 2, but less than 3.5. Which integer is there less than 3.5? 3. Therefore, I have to consider up to 3. Even if the answer comes 3.9, I should take only 3. Even if the answer comes 3.99999 like that, then the ceiling function would be how much? 3. Similarly, integer closest to capital M by 2, but greater than capital M by 2. In case if the value comes 3.45, then what will you do? You will take 4. So this is called a ceiling function. If you write as it is, then it is the equal value. It is equal. No approximation. Therefore, how many zero crossings would occur? M by 2 zero crossings would occur. I am considering the total length 0 to pi. So therefore, your phase angle h of e to the j omega is minus omega times capital M minus 1 whole divided by 2 plus del of omega minus the zero crossing at occurs 2 pi by m, 4 pi by m, 6 pi by m. Therefore, let me put k here, and you sum them up all the phases. How much phase occurs? Pi. And you start from k is equal to 0 to how many transitions will occur? Capital M by 2 transitions. So this should be a ceiling function. Okay, therefore the upper end is truncated, okay, to the closest integer, which is less than m by 2. Okay, now let us plot the magnitude as well as phase for two values of capital M. Let us say capital M is equal to 5, and let us take another case, capital M is equal to 14. So if you plot the magnitude, then the first zero crossing occurs at 0.4. This is normalized scale. Okay, so this is m is equal to 5, and then the next occurs at 0.8, and then it goes like this. This is 1. Okay, this 1 corresponding to how much? Omega by pi. This is my omega axis, omega by pi axis, not omega by pi. Therefore, the first transition occurs at what value of omega? We said m by 2, right? Where m is 5. Wait a minute. sorry, it is normalized scale. Therefore if you look at here, 2 pi by m, right? The scale is not omega scale, it is omega by pi. Therefore 2 pi by m, this pi you remove because it is normalized. Therefore 2 by m, so 2 divided by 5, this is 0.4. That is why you got 0.4. The first zero crossing occurs 0.4, and the second zero crossing occurs 4 by m, that is 4 by 5, this is 0.8. Now third crossing occurs at 6 by m. 6 by m means 6 by 5, it is 1 point something, so you will go out of the vision. So I need to look at up to 1 only, so I have only 2 transitions. Let me put a box like this, so it will be easy to understand. In case if you try to plot for m is equal to 14, then this guy comes here, and then there are many transitions. Okay, 1 2 3 4 5, I think there are some 6-7 transitions. You can calculate and you can check it out. And here the ordinate is not omega, ordinate is, it is normalized. Okay, the ordinate x here is omega by pi. So the first zero crossing occurs at 0.4, the next transition occurs at 0.8. So there are only 2 transitions for m is equal to 5, because 5 by 2 is equal to 0.4, sorry 2.5, and the integer closest to 2.5 is 2, right? 2 by m, look at the upper bound. What is upper bound? M by 2. In this, m is 5 and 2.5, ceiling function of 2.5 is 2. Therefore only 2 zero crossings. That's what we have. That is why we have 2 zero crossings here. And the next one is pi at 1. There are no more transitions, and therefore it stops. Now let us look at the phase. So this is the magnitude. Now let us look at the phase plot. Okay, let me draw a box, and this line is 0 degree. Okay, let's say this is 0.4 and this is 0.8. So initially it is negative, it comes like this. When 0.4 comes, at 0.4, 0.4 what happens? If you look at the plot in the sinusoidal, in the sinc function, sine by sine function, at this point, look at here, there is a phase reversal of 180 degree. Okay, so it introduced an amount of pi. Therefore there is a jump at this point. So this part is, this linear contribution is coming because of minus omega times m minus 1 divided by 2. But when omega is equal to 0.4, I mean normalized frequency becomes 0.4, then there is a jump. How much jump? Pi. This jump comes because of your sine omega m by 2 divided by sine omega by 2. And again it gradually decreases, and when it reaches 0.8, then again there is a jump of 180 degree, and again it goes like this. Look at here, this line and this line, these lines are parallel lines. I didn't draw as a parallel line, but they are parallel lines. At 0.4, at this point, at 0.4, this height is exactly equal to how much? 180 degree. It goes up by 180. Why? Because the quantity sine omega capital M by 2 remains negative for how long? From 2 pi by m to 4 pi by m. Okay, when it remains negative, the phase is controlled by that minus omega times m minus 1 by 2. So it comes down slowly again. Okay, this line and this line and this line are parallel. Then at the next transition point, I mean point 8, again another pi is there, right? That is at point 8 there is a jump of this 180 degree. Okay, there is a 180 degree phase, this point 180 degree. So the phase becomes a triangular waveform with a rising tendency. And the phase is not minus omega times m minus 1 by 2. You have to stay the phase within the range of vision. When capital M is 14, then you see the transition occurs less than 0.2. Okay, let me draw rough diagram. It comes like this, goes, comes like this, goes like this, like this. So this indicates capital M is equal to 14, and this one indicates capital M is equal to how much? 5. So how many transitions now? 14 by 2. It is an integer whole number, exactly 7 transitions. And the 7th one is the end of the vision at omega is equal to pi. So the phase behaves in a peculiar manner. And in specifying the magnitude, we have no peculiar manner, right? Magnitude is very easy, explicitly you can specify. But there is a ambiguity in specifying the phase. Okay, ambiguity in specifying the phase, and no ambiguity in specifying magnitude. Okay, because you have exponential term, and also at every zero crossing of your sine omega m by 2 divided by sine omega by 2, there is a phase reversal. From here to here 180 degree, and from to there 180 degree, and from there to there 180 degree. So that we need to take into account. Okay, therefore in specifying phase, the transitions must be taken care. Okay, so you cannot simply say that the phase is linearly negative. See, if the phase this term is alone is there, minus omega times capital M minus 1 by 2, then the phase is linear. But here the phase is not linear. In addition to this, there is one more phase transition. That phase transition comes because of this guy, omega m capital M by 2 whole divided by sine omega by 2. Whenever it crosses 0 axis, then there is a phase shift of 180 degree. When will it cross 0 axis? At 2 pi by m, and then 4 pi by m, and then 6 pi by m, and so on and so forth. 0 to 2 pi by m, no phase transition, it is positive. Okay, 0 degree phase transition. Then 2 pi by 2 by m to 4 pi by m, how many phase transition? 180 degree. And then 4 pi by m, this is a 0 crossing point, to the next 0 crossing point is 6 pi by capital M, then another 180 degree. So totally how much phase shift? 360 degree. So that we have to consider. So how do you write this in terms of mathematically? Del of omega minus 2 pi by m times k. When k is equal to 0, you will get del of omega. Del of omega when omega is equal to 0, 1, therefore 0 degree phase shift. 0 to 2 pi, 0 degree phase shift. When you substitute k is equal to 1, then del of omega minus 2 pi by m, and this guy is multiplied by pi. Therefore it gives 180 degree phase shift, and so on and so forth. Therefore specifying the phase is not that much simple job, but specifying the magnitude is very simple. So there is an ambiguity in specifying the phase and no ambiguity in specifying the magnitude. Okay, so let me stop at this point. We will continue from here in the next class. Let me stop. Thank you very much.